Hashcat, of course, has much more different hashing algorithms available for cracking. So let's just review them. It's quite large. So there are different options. So we can use, we can specify the mode. There are many, yeah. So there is a reference below, and 1000 I think stands for NTLM. Yeah, I think so. We'll check it out. And there is attack mode. It's also can be different. We will see what are the values, and these are all the different ways you can customize the work of Hashcat. So it's highly sophisticated. It uses different approaches. Markov models, for example, is quite a novel approach to password cracking and data analysis in general. So we can do that. We can work with it at home, I guess. So please, I encourage you to play around with Hashcat with different password databases. Just because there are different flavors of it, right? You can dump something from a Linux box you have, you can dump something from a Mac OS, you can dump different Windows versions and databases, and just see what happens. Okay, so it's really cool. It gets everything from the hardware components you have in the system, but in the best case scenario, of course, you will still have to rent or create this large multi-core cluster with a lot of disk space for rainbow tables, and use that on the night time, right? So to do that more effectively. But yeah, for now, let's just review the hashing algorithms that are available. Of course, there is SHA1 as -M100, and 1000, of course, stands for I'm almost sure NTLM, of course. So what are the modes for -A? It's straight mode. I guess it's just comparing the hashes with the given values, and there are some other ways to optimize that. We can brute force with a char set, I guess. We can do some hybrid word list combinations with some mangling by masks and so on. So this is quite a lot to play around with, and much more than one demonstration could fit. So let's just do that. Yeah, so let's run hashcat against our hash values. So for that we will use NTLM mode, and let's just give it the file and give it the password list. Yeah, so this of course will be something from seclist passwords, and I think that Raku will do. Okay, so Raku is one of the most comprehensive password collections. This is the leak from Raku.com, as far as I remember, and it's sorted by popularity, so let's use that. So it says that this 1000 mode is not in cache, so they are building that. And yeah, I think there is a binary for hashing that is cached between hashcat runs. So you see, it's quite cool. Okay. What now? And it's done. So I think that password is quite early in the list. Okay, so that's why this hash has been broken like in no time. Okay, so let's do the same for the other hash, the SHA1. SHA, as you see, of course, is not yet in the cache because I ran hashcat for a second time on this machine. So we can see that it is built as well. And after that, shortly, we will have it started up, and nothing really happens. Okay, so yeah, it says okay, that's SHA1, but for some reason it doesn't crack it. The second time, of course, it does it much faster, but I think that's for some specific reasons of SH1 hashing algorithm. Most probably there is some salt that Hashcat is not aware of. So let's try to do straight attack. No luck. Okay, so at least you can see that NTLM is much more simple to crack with Hashcat than SHA1. Yeah, so let's keep it for a homework. Figure out why SHA1 dumped from Windows 10 is not cracked by Hashcat and its algorithms. What is the exact reason? Okay, whatever. We can do that in other way, right? So we can just try to Google this string, and most probably we will find it online. Basically, every time you find the hash, the first temptation will be to run some Google search on it. Yeah, so someone did this exact sequence of actions we performed to dump it, and they have posted the hashes online, and someone most probably have tipped them off that that's a password. Oh no, that just was another version of Windows, and they have dumped that in clear text as well, so that's why it's indexed. So anyway, it's somewhere there, and you can find it easily by using Google, by simply googling the password hash. Okay, so that's it for password cracking for now, I guess. Let's get to other hacking tools.